visual patterns. So Fawn, I'm going to let you go ahead and take it away.
She didn't mean that amazing part. Thank you so much, everyone. Yeah, especially to those of you who are in a different time zone. It's later for you than my 6 p.m. California time. We are in warm-up. It takes about 10 minutes. 10 to and a few times it goes to 20 minutes. And it's hard for me to stop when kids really want to share. So it's all good, but most of the time it takes about 10 minutes. I would love for you to have paper and pencil so we can do these visual patterns, even though it's kind of ironic when I learned that I can't see you and I can't see your visuals, what you do. So even though it's visual pattern, I'm thinking maybe you can tweet out a picture of your work. I can see the tweets. I think I can see the tweets. And yeah, just because it would be really lovely to see what you draw. If not, if you can put it in the chat box and describe what it is that you drew. Okay, so what we're trying to make do. And other than, this is awkward for me because I just hear myself talk and there's limited interaction. So yeah, so it's kind of boring on my end just hearing myself, but I'll live. Okay, I'm hoping that when you do decide to incorporate visual patterns into your day, that it's hopefully you're able to do it at least once a week, preferably twice a week. That would be great. Other than visual patterns, I also do number talks and some estimation. And we're on a block schedule, or we were. I'm speaking as if I'm still in the classroom. Yeah, so it's 90-minute blocks for us. Anyway, nobody asked about my new job, but I'll tell you about my new job. It's going great because I'm not doing anything yet. I haven't gotten into the classroom yet, but I'm hoping that will pick up really soon. Tomorrow, I get to give my first PD for the minimum day for 2 hours to the 6th through 8th math teachers. So yeah, I'm really excited about that. And hopefully they will invite me into their classroom or not. Okay, so let's get started. I'm trying to get rid of this. Okay. I want to always start out with a quote from someone. This is from Lexi, a 6th grader last year. I just loved that she said this. No one is born smart in math. You just work at it. And this was in response to a student saying, I'm not smart or something. And she just kind of snapped at this kid and just said it with conviction. So I love that. And I asked her if I may quote her on that. Okay, so we're going to dive right in with our first visual pattern. This is number 168 from Katie. And what I like you to do, the way that I'm running this is like, this is my first time with students. And it would be, okay, and of course you will have to adapt it to your students. You know your students best. And hopefully, you see where you can adjust accordingly. But so I'm running through this as if you're running this for the first time with your students. And last year I had 6th graders. And actually, I think all the examples I have intentionally are from my 6th grade students, okay? All right, so if you can draw step 4, do some notice and wondering if you can draw step 4 for me, the next step. I normally allow depending on the pattern, about 2 minutes for them to draw the next step for the first time. And I also have to tell the kids that please don't draw flowers. You see flowers because that will take forever, right? So just draw circles, boxes, whatever. Just, use X's, something, because the idea is not pretty flowers. The idea is just to get the pattern. Now I'm going to, I hope you don't mind, since I can't see your drawings anyway. If I'm speeding things up, right? Just so that you can get the content. So I allow about a couple minutes for this. And then after the step 4, I would ask for step 10, just so that I'm forcing the kids to think farther downstream, right? So instead of asking for step 5, which just comes right next. So the idea is just to have them make a leap. So I go to step 10 next and ask for that. Okay, so if you can quickly sketch that too, just to play along with me. And visual patterns, I hope, and I tweeted this out yesterday because two teachers just, I guess it was wonderful timing. I have a third grade colleague, a third grade teacher, and she said, her kids love visual patterns. And then another teacher, Paige, she said her Algebra 2 kids love visual patterns. So it's so wonderful to hear from elementary. I'm at the middle school and then high school students. And actually, I just got an email from a college professor who's doing this with his students. So yay. Oh, the questions, the two questions I asked as the kids are doing this are, what is staying the same? I'd like you to pay attention to what part of the pattern that's staying the same. And then the other question is, what part is changing? Yeah. Okay. And also, by, the sixth graders, hopefully my sixth graders, they know how to find the area of a rectangle. So I also ask them, do you see a rectangle that it can grow or it can stay the same, but you see a shape of the rectangle that you can form. So these are my three key questions that I throw all the time. All right. And then next, I ask the kids to share their sketches with a neighbor. Okay. And I wish we could do that here, but we can't. This is 1 minute. This is exactly 1 minute. I put a timer on it. And oh, yay, I get to see some patterns on Twitter. Thank you so much. Yay, thank you. All right, so this is a 1 minute deal. They turn to their neighbor. And then I tell them I'm going to call on 3 students randomly to share their sketches with the class. Now, you will, of course, have kids, especially at the beginning, who say they have nothing on their paper. They just didn't get anything. And of course, that's perfectly okay. And, even if you do this towards the end of the year and you still have a kid that says, I don't have anything, I've not had that situation, but you can still have, up until winter break, you might have a kid that says, I just don't have anything. I don't see what's happening. Please, please, please do not move on to another student. I need you to stay with this student because, right, we want participation. We want kids to be sharing. So the first thing I say is that's okay. And then I say, we'll work on it together. And that's exactly what we do. I ask this kid to come up with me. And then we just put the student's paper under the dock camera. And then I ask those 2 questions again. What part do you see? Is there any part of this pattern that you see staying the same? And what part is changing? So I repeat those questions and then just help the kid out and just see whatever. And we use colors a lot, and you get to see how the kids use colors to identify the different parts. Okay. And then, again, reminding you this is the first time we'd run through this. Then I ask the kids, hey, well, let's go really farther down the series. I'm going to ask first randomly. You can make it any step, but step 87. What would step 87 look like? And of course, no pretty flowers or no flowers at all. Just do a really rough sketch, like, what's on the first row. If you see them as rows or columns or rectangles, anything at all, just do, dimensions of what you see. Just make it a quick sketch. Okay. And then I ask just one person. Remember, I asked for 3 random students before. Oh, I need to go back. After I ask those 3 random students, then I open it up to the class and ask who else sees it a different way. And we'll get more into that. I'm going to repeat some of this and have it written down for you in other slides. But anyway, so I would ask, would anyone like to share the sketch of 87? Okay, so again, a quick sketch, and I just ask for one person. And also, it's important. You can have kids, you can, instead of having them share the step visually under the dock camera, you can also ask the kids to just describe it with, just describe it with words. So to work on their language skills, right? So that they are descriptive and and so fine-tuned so that you can get all that language out also. All right, so to summarize what I've done so far, I think I have. I call this stage 1 because eventually I have 3 stages. This is the beginning stage. Okay, so I ask for a quiet work time, right, to sketch step 4 and 10, about 2-3 minutes. Share with the neighbor for 1 minute. We have to be intentional about the time just because it is a warm-up, otherwise we get carried away. In the step 3, call 3 random students. 4, back to the drawing board with step 87. Okay, 5. So so I just summarized what we just did. And then get the kids to, well, I've asked you for step 4, step 10, step 87. I can keep asking, but can we generalize to any step? What if, on any step you can describe it? How are you, so that I'm getting them to describe the step number and how many flowers are in that step, a general picture of it. Okay, I'm going back to the visual. Okay? And then hopefully from there, we link it, bring up the equation part. All right, so again, step N, if I can get kids to draw step N or describe it to me, then the equation is the easy part. It really is. I mean, even with 6th graders, and that's the beauty of this, is because they can't be wrong in what they see, or they may have some missteps, and I'll show you those. But again, it's just practice, right? Anything that we do diligently and practice, we just get better at it. Oh, oops. So anyway, I'm hopefully you have some sketch, and here are 3 ways, I think, 3 different ways that my students and I saw this. Okay, so shout out if you saw it the same way. So I get kids, so this is what I mean by the colors. And do you see rectangles? Because if they see rectangles, we are just down to 2 dimensions, right? We want to see the inside of the rectangle, how many objects are in there. And if we're looking at the inside, we're just looking at area, and area is just length times width. So it focuses them on just the 2 dimensions, and it brings home that whole thing about, the inside of a space. So we box it up as a rectangle, and now just, horizontally and vertically, how is this rectangle growing? So yeah, I'm assuming you saw it this way also. Okay, and so I get the kids to talk to me about step 20. Right, they're describing step 20, and then from there we introduce N and the variables. We define the variables. I don't know where N came from, the letter N came from, but we'll just use that from now on as a step number. And in this pattern, we're going to use F for flowers. And yeah, so the yellow is a rectangle with the dimensions of the width is always N wide. So focus, have the kids, they don't get it at first. So for example, I just point out, the 3 patterns that they see. Step 1, how wide is it? And they can say 1, and they'll say 2, they'll say 3. And then that's when I ask step 20, how wide is it? And they may or may not get it, but then, so I just don't give them the answer though. I just keep asking. I go back to step 1, how wide is it? So just for them to hear that step 1 was 1, step 2 was 2, and then they of course eventually will get it. And then, just patience, and the class is remarkable. The classmates are so kind and so patient because they're seeing it, and sometimes they'll help me help the student who's struggling to see. And the height of this rectangle, we notice that that's the part that stays the same. It's always 4. So length times width, or N times 4. Plus the extra purple part, we notice that it's always the step number plus N. Okay. Here's another way that students can see this. Because that second row, right, it's longer than the rest, so it's extra special. It is twice the step number. The number of flowers is always twice. And then, of course, the green parts, we notice 3 groups of N, right? 3 rows of N. It matches the step number. Okay. My students, remember if I told you that I call up 3 random students, but should those students, especially later when they get better at this, should those 3 students take the ones that they have on their paper, what they do at their desk is scrambling to see it a different way so that they can volunteer to come up, because I do ask, after the 3 random students, who sees it a different way to come up and share. So it's so great. I mean, it's a great problem to have that kids, are scrambling to find another way to see it. So this way it's getting more common, which is seeing the negative space. So they'll see the whole thing as a rectangle. The height is still 4. But the width is always twice the step number. So 4 times the quantity of 2N. And then what is not there? We count it, flowers are not present. And we notice 3 groups of N. So, so kids will do that. So hopefully, we get to match, right? We're writing expressions and coloring it so that it's easy for kids to pick up on, and they understand it. They're writing these really long equations that you see later. And it doesn't matter how long it is. They understand each part of it. That's what's great. All right, so these are the 3 questions, key questions again. Okay. All right. Here's another one. Let's do this one, please. This is from Eric Appleton. He's given us some great patterns. So please, if you can draw step 4, I'm going to pause so I can take a drink of water, but please draw step 4, please. I'll put a timer on for 1 minute. I'm kind of hoping you would tweet out an image of your step 4. I'm also reading some tweets and looking at some pictures. Thank you so much for doing that. Okay. All right. So this is the awful part of this is I don't get to see your drawings. All right, so I like to, before I show you what my students drew, I'd like to share with you some missteps. I intentionally picked this one because it's easy to see the wrong parts, so it's good to see these mistakes come up, and so we can talk about these. Sorry, I don't know why my... Okay. My advanced button is not working quite right. Okay. All right, this is what I mean. It could a possible misstep. The student is seeing the part that sticks out at the top right? On step 1, there's 1 sticking out. Step 2, there's 2. And then, oops, step 3 doesn't have, it's missing. We want 3 to be sticking out, so it's not. I just tell students when that happens, it either grows consistently so we can predict the next step. If it's not, just abandon it. Look for something else, right? Look for something that's that stays consistently so that we can predict, or whatever, something that stays the same. So that might be one that they see, the misstep. Here's another one. Okay, they can see the entire top row seems to be working, follow some pattern. There's 3, 4, 5, right? The reds are growing as we expect it to. And then the second row, then we see 2, 2, and then oops, it's doing something funky that we weren't expecting. So again, I tell students, if this happens, you just simply, see something else, try to see something else. Okay, kind of stand back, right? Stand back and look at the pattern again. Also, here's another one. We have a 2 by 2, and then a 2 by 3, and then we want a 2 by 4 because, right, the first 2 steps have the width of 2, and then so we expect the third step to also have a width of 2, and it doesn't, and that kind of, okay, so we have to abandon that. Okay, so I just want to share with you some that my kids had done that were not consistent. So, all right. So these are what my kids did, and hopefully one of these matches what you saw. Okay, and so again, the colors, the colors are everything to the kids. And you see how it plays out more later. So we got the top row is green. That's always twice the step number, not twice, I'm sorry, 2 more than the step number. The yellow is a square, step number by step number, or n squared, and the red sticking out is always a step number. Yeah, so they need to do that kind of matching. Here's another one. And I wonder if yours is anything. Okay, if you saw any one of these, remember these are my 6th grade babies, whom I miss dearly. Another way. And this one. I like this one a lot just because the purple part, right, the middle rectangle, you don't see it in the first step because, yeah, we talk about why is that? Well, it was a 2 by 3 on step 3 and then 1 by 2. So we expect a 0 by 1, right? If things are in 0, well, 0 dimension, that's why we can't see it. So notice the kids are writing quadratic equations without me because it's 6th grade, without me ever saying word quadratic. We don't have to wait until then. They're just writing equations based on what they see. So here's another negative space one that someone did. That the visual is not as satisfying just because you have to move that green piece sticking out on the 3rd step into there. But the missing part is matches the step number, right? 1, 2, 3. Except, yeah, you have to move that green one. Okay. So I'm going to show you stage 1 again, kind of everything that I flushed out, and that takes time, right? Anything, it takes time, and hopefully you are, you will persevere right along with the kids. And I tell them never give up, so we can't give up either. Please stick with the kids. It really is very powerful to see the growth in them. Okay, so very quickly, and really I mean quickly because this is still a warm-up, right? It's still warm-up time. You need time to do your other stuff. So I eventually, and this is up to you, when you see fit, you start taking away steps just because it's just not good time, good use of time. This sketch step 4 and the sketches, once they're used to it, they can sketch it because they're writing the equations for it already. Okay, so those are the ones that go away, and I'm just going to give you the stage 2. When you scratch all these out, this is what you get. Okay, so it's doable, right? I want you to be able to do something and not say, I don't have time for visual patterns. We say that a lot, but well, what are you making time for? I certainly will always make time for visual patterns, and I only do it because of the growth that I see in the kids. I normally don't get to do step 4, which is teacher shares her way, because one of the kids will have it already. Rarely do I get to do that. But I just want to make sure that you also share your way. Or you definitely say, oh, so-and-so, my way was the same as Sophia's or was the same as Jose's. Yeah, they love that, right? Because, yeah, you had the same thinking. So here's stage 3. And I don't remember the timeline when we get to stage 3, but for sure before Christmas break. Yeah, okay, so you always keep that quiet work time so that they can write the equation. They're not drawing sketches anymore. They're trying for the equation. And now step 2, notice it's slightly different. I'm still calling on those 3 random students, but they either share the equation or the colored part of their pattern, not both. And our class will work on the other part, and I'll share with you what I mean by those, okay? And then step 3 and 4 are the same. Okay, so here's what I mean by step 2. So it's wonderful. I'm so glad I started doing that because it gets more kids participating, right? Where you want kids to be involved as much as possible. I mean, it's about them. Oh, this is one of my kids' journals. And so I make a pattern, I just copy it 3 times because remember we're sharing, we're trying to see as many different ways as we can. I think I used to have 4 patterns, but this is half sheet that fits, that gets glued onto their journal, their math journal when we're done. And I just noticed this as I put the slides together, this is August last year, people. So by August, which is just, like a week or 2 weeks in, my kids are doing this, right? So so proud of them, but this is what they can do if we do it diligently and faithfully. So yeah, this is the 2nd week or 3rd week in. 2nd week, because it's still August, okay? All right. So this is what I mean by change it up a little bit. So instead of this kid bringing the pattern up and I just show everything under the dot camera, I cover up the kid's equation and just share with the class the color parts. And then I call on random students. I would say, Bobby, pick a color and tell us about the color in the equation. Okay, and then pick another student, or let the student pick. Pick whatever color you want and tell us about it. Okay, and that's what we get. So hopefully, the rest of the class we get to work on the equation based on how this student sees it. Okay, and again, if that student doesn't get it, you just don't give up on the kid. You can't. You just keep working on it, and then helping and just keep asking. Well, not the same question twice, but just kind of guide them along. For example, go back to just asking for step 4, step 5, step 10, and then just make and then step 100, and then get them to work on N. They're always able to, always 100% of the time. When I don't care, I'm not looking at the clock, because this is what makes or break a kid. When they will know if you've given up. Maybe they've given up, but you're not going to. Okay. So here's another one. So see the rectangles, right? What stays the same? And do you see rectangles? See, we're breaking it down so it's easy and it's fun. Here's the negative space one. Right, they see the whole rectangle, and then the missing part. What's great is they learn to put in parentheses correctly, and then later in 8th grade you can have, or later when it's time to learn to distribute, they've had these skills. They can distribute correctly, and then we're combining like terms. Right now, we're just trusting that we all have really the same equation. It just represented differently because we saw it differently, right? But there's great trust in that we are looking at the same patterns. And so our equations would be the same. Taking the time to simplify, if you have the time, great. It's just my kids, this would be, right? They would be distributing, double distributing, so that's just not a 6th grade thing. So we're just representing the equations that we see it. The length times width, right? The first part, length times width minus what's not there. Okay. So here's the other half of it. So it's just the opposite. A kid, I would cover up the kid's color parts and just show the class the equation. And then I have a blank pattern for us to color in. Where does the student see these 3 different parts that we see? Okay, so where is 2 times the quantity of n plus 1? Okay, that looks like a rectangle, or 2 groups of n plus 1, that kind of thing. When they see multiplication, 2 quantities being multiplied, they're looking for dimensions of a rectangle, things like that. And that plus 1 is a constant. Where could it be? Right? And so we as a class try to find these different parts. And we ask, of course, the owner, do we get it right? Did we mark the right patterns? This one, see how long it is? They just kind of break it up. Yeah, so we have a square, it looks like, right? The n square, we have a square in there somewhere, and we've got a plus 1 toward the front and a plus 2. Okay, yeah. So I would call on a random student, and which of these parts you think you can find. This one, look at the brackets, right? You have the brackets. So yeah, just getting kids to just be careful with that stuff. Training them early and getting them to be mindful. All right. So the website, if you haven't seen the website, I meant to just have 180 patterns on there, but people keep sending them to me, so I'm very grateful. This really is a collaborative effort. I may have 50 patterns in there at most, so the rest are from students and teachers and from across the country, across the oceans. So I'm just very grateful that this is out there for us. Okay. Zach started tweeting this out last year, and I asked him if I can use his tweets in trying to convince teachers to use visual patterns. And so here they are, what Zach says about using patterns with his 7th graders. Yay. And I did not pay Zach to say all these things. So cool. And I always appreciate hearing and seeing pictures from classrooms. Okay. I made this pattern, and my Oregon Ducks, go Ducks. I made this pattern, and I want to share something with you that I always share when we talk about visual patterns. So it's a pattern, and I'm asking you to do this because I see teachers do this for, when they first see a visual pattern, they tend to do the table X and Y because that's how we normally, before we write an equation, we tend to do this and find the common difference. And the problem is when you teach something, it's very difficult. It's harder to unteach. You can't unlearn something. You can't unsee something, unhear something. So once you teach them using the table, unfortunately, that's all. You've just boiled this my beautiful Ducks pattern into numbers, just a bunch of numbers. And we've lost the visual completely of the visual pattern. So if you could hold off on this XY table until like in starting algebra, when you need to talk about connecting it with slope. Remember, I keep asking. So imagine kids hearing me talk about what is changing all this time. Then 8th grade, it just flows right into the change is your slope. And you can have that conversation. But yeah, so please, if you can hold off on the table. I'm not saying not to use it at all, but I mean, when I first started out visual patterns, I also use the tables, but then I realized it was robbing the kids of the rich beauty in the pattern itself. Okay, and my next slide shows you if I taught the kids the table, I would not have all these, and here they are. Okay, so that same pattern. These kids don't know how to set up a table. These are 6th graders. Yeah, my 6th graders are the best. I don't know about yours. Yours might suck, but mine are great. No, kids not. Kids are great. So 6 different ways to see the pattern. Remember, they're always trying to find. For them, the challenge is not even writing the equation anymore. It's trying to find how many different ones they can write. And that kind of motivation I'm super proud of. Okay. All right. And then just to, and my 8th graders, honestly, because who have done visual patterns 6th grade, 7th, and by the time they get 8th grade, it's hard for me to find, patterns that would challenge them. They're doing them so quickly and so great. So just to mix things up, I started doing this last year or 2 years ago. So I just give the kids one step, and they give me the step before and after. So if you could take like 30 seconds, please do the same. Can somebody talk to me like Sheila? Am I still on?
Yes, you are. You're doing great.
Thank you. Oh my God. I've just been talking to myself.
Giving them step 2. I never even thought of that.
Oh, yay. Awesome. Thank you. I've just been so quiet. I'm thinking, God, I could just been, people are telling me I can't hear you, Fawn. And okay. All right. So how did you do? Want to see the answers? Right. Nope. The obvious love is there's no right or wrong answer. I go back to those questions. If you find yourself having a hard time writing the equation, maybe you didn't draw it consistently. Things that didn't grow consistently or didn't stay the same. So here they are, what my kids did. And I have to always point out the bottom right one. When Manny saw that I was taking pictures of these to share, he had to write his name right next to right where the patterns are. So this is bottom right is Manny's, just so you know. Okay, so of course the equations to match the different parts. Right? How great are these? I'm hoping one of these is yours or not. And if you can share that also on Twitter, I'd love to see it. Okay. And when these kids had shared, I just realized, oh, you know what? I'm seeing two colors. That you're seeing the pattern in two colors. So I just toss out a challenge. How about you see this pattern? Have your pattern grow in 3 colors. And these kids took on the challenge. Okay. How wonderful is that? That I noticed something. And for me to ask to challenge them, and they just ate it up and wanted to do that. That bottom one is, the quadratic equation, right? It's making it grow like that with no green on the first step. I love my kids. It's so good. All right. So the point of this, I just want to say, right, I've been saying step 1, 2, and 3. That's all arbitrary. Well, make the first one step 0. Then that's how you get your y-intercept when you start talking about linear equations, right? Let step 0 be your first step. And now that just flows right in. It really is wonderful. And kids can see they can see in a pattern what the y-intercept looks like. And if we can have step 0, why not have step -1, right? Okay, so make that whatever you want, make the step number. Okay. This next pattern I want to point out, just because and we have some time, it's quite common. It's quite common. So if you're new to visual patterns, I want to make sure you get a chance to see this, because you will see this type of pattern either in a bigger pattern or by itself. So this is from David Weiss. And so if you notice what's happening, okay, if you're seeing this for the first time, these are triangular numbers. And I drew a triangle on top just because these are right triangles, and sometimes they're referred to as triangular numbers. Okay? Most of the time, though, the triangular numbers are illustrated as these equilateral triangles, more equilateral shape. Okay. All right. So if we count the number of squares in each step, the first one has 1, 3, 6, 10. And my kids, by the time, again, just exposure, they're used to seeing this, and they know that, oh, yeah, step 3, the third triangular number is 6, so on and so forth, because they're just familiar. They become familiar with the 1, 3, 6, and 10, and so on. And then we pay attention that, where are these numbers coming from? The sum. We notice, oh, the sum is coming from their consecutive integers, right? We're just adding on an extra tile, an extra set with every step. Okay, so seeing this, right? This is the 10th. I guess we can call this the 10th triangular number, and it's from adding all these numbers up. So how many total squares are there? And because this is so common in visual patterns, I kind of teach this separately, help the kids out separately. And I give them that Gauss story, the German mathematician Gauss. And supposedly, the story goes, he was given the numbers 1 through 100 because he got in trouble. He couldn't go out recess. He had to add the numbers 1 through 100 and before he could go out and play. Well, he did it within seconds, I guess. And I don't know how the teacher checked to see if he was right or wrong, considering they didn't. But anyway, he got the correct answer. And so I would have, teach this separately and have the kids notice, do they notice anything? Is there a faster way to add this instead of 1 + 2? Okay, what is a faster way to do this? And this is what you can help the kids draw out. Normally what I've seen people do is 1 + 9 is 10. And then 2 + 8 is 10. That's fine too. But if we don't want to neglect that 10 at the very back, so we can go ahead and do this. And then we notice, right, we have, we notice that if you take the front and end, we always get the sum of 11. And so, okay, so 1 + 10, yeah. And so we always get that 11. And how many pairs of 11s would we get? Well, we have 10 numbers, so the number of pairs would be half that, it would be 5. And so walk the kids through this and and write it out, do what you need to for the kids to understand, and then you just practice it, the number of pairs. So I write this, and later, especially the 8th graders, or even my 6th graders, they just use the Gauss as a verb. I Gaussed it, meaning they add it like this. So I can ask, for example, how many red squares are in step 43? If you can walk this together with me, right? We want to take the first plus the last, and then multiply by the number of pairs we would see. So if somebody wants to know step 43, for this particular pattern, the first step is always 1 plus the 43. Imagine, look far way down to 43, we would have 44 as a sum. And then how many pairs? It will always be the total, 43 divided by 2 to get pairs. And yeah, all right. And I want to refer back to this just because these two students use that addition, right? That Gauss addition. You can see the quantity n divided by 2, those are the pairs. And we write it that way. I don't intentionally not simplify that at all, just because that's how I saw it and how the kids could see it. It was really adding the first plus last, add that first, and then multiply by the number of pairs. So yeah, we keep it like that. I don't simplify things just because it doesn't make sense to me. You simplify and then you lose the beauty of, things that how they saw it. Okay. I'm going to leave you with, in terms of visual patterns, with this one. This is pattern number 100 from Simon Gregg. And I tossed this out to my 8th graders. This is an 8th grade one that I tossed out. And I just want to tell you that one of my 8th graders figured out the equation for this. And, it's kind of made my day. You think kids can't do stuff, and we couldn't be more wrong to determine what they can or cannot do seriously when it comes to especially visuals. They can see richly. Okay. All right. I'm actually excited that I have some extra time with you. So I'm done with the visual patterns for now. Please, please, please. I'm available on Twitter. Email me or just tweet me something, and I would definitely get the answer for you if I don't know the answer. Okay. I just learned this estimation game in New York when I was in New York. No, not New York, Ohio. I lied. In Ohio from Chris Boglonis. And you get a copy of the slides, right? And the template is from Slides Carnival. Anyway, so I learned this game that I'm really excited about from Chris Boglonis and Sean Corey. They ran this game at a happy hour event in between the conference. And I would love to share this with you. I think I have time for this. Okay. All right. What it is here's an example question. Okay? How many traffic signals are there in New York City? Okay. So I'm going to do the same with you. They had like 12 questions, but if you want to do this for a warm-up, you can just ask one question. I think I'm going to ask 3. If I had a group of kids, I would ask 3 questions, just so that if they miss one, it's not so bummed out. They've got 2 other chances. So there are 3 questions like the one you just saw. Each team gets to submit 2 estimations, however, for each question, a maximum and a minimum, right? We want to sandwich our estimation kind of safely between the 2. And then we're going to divide those 2 numbers, find the ratio, max to min. And, you can have this discussion with the kids. What do you want? You want a high ratio or a low ratio? Get them to understand that, the lower the ratio is, the better is the score. Okay. And then because there are 3 questions, you would get 3 ratios, and you would add these up, and that would be the team score. However, if the actual answer does not fall within your max and min range, then there's a penalty, of course, right? You can't just ask, guess wildly. You gotta, so it's estimation. So this is how your penalty comes in. The score is you take the sum of the 3 ratios, we mentioned that, multiply by 2 to the power of the number of incorrect. So there are only 3 questions. So if you have 3 incorrect, it would be 2 to the 3rd, which is 8, right? So the sum of your ratios might be nice and small, but then now you have to multiply by 8. And remember, we want the lower the score, the better. And I can give you a copy of the spreadsheet too. It just has the formulas in there, okay? So for example, I intentionally gave team 1 and team 2 the first exact same numbers, how unrealistic is that? But anyway, just to share the point. So, the teams give me their max and min, right, for the questions, and then I calculate the ratio. And then look at question 3. Team 1 gave me 40 and 20, so that's a ratio of 2. Team 2 gave me 80 and 40, also has a ratio of 2. However, let's say the correct answer is 30. So team 1 is fine. The answer is within the range. But team 2, 30 is not in between 40 and 80. So therefore, they get dinged with a 1. That one is incorrect. So I would highlight it yellow. And and that 1, right, that made it 2 to the first, which is 2. So 2, that's why team 2 score is twice team 1 score. Yeah, sucks for them. Okay, of course, they may not use, they can't look up the answer or calculators, just paper and pencil. All right, I would love for you to do this with me, okay? What is the weight of a, okay, and don't look it up just because you're at home, I can't see you. What is the weight of $1 million of quarters measured in pounds? How fun is that, Okay, all right. Honestly, give a max and min if you're still playing, if you're still awake. God, I'm sorry. I don't know, give the kids maybe the teams, right? This is in teams. Oh, please do this in teams. This is one of those, yeah. It is just too scary to do it alone. Yeah. So that's why teams of 3. And if you've heard me talk before, I always have teams of 3. I don't know, 2 is just, 3 is perfect for a team. 4 is a party. And I cannot have that kind of party in my room. Okay, we're doing mathematics, which is fun in itself. You don't need to have a party. So teams of 3 would be great. Yeah, especially these estimations, just because I don't know. I would want to talk to someone about this. This is just kind of too scary to do this alone. All right, so I don't know. I can't see your answers. I don't know what the heck you wrote. Okay, so imagine you give me your max and min, and then you would we would divide the max divided by the min, and that's your ratio. And you want that to be as low as possible. And ask the kids, what is the lowest ratio you can get, right? If you had the exact same answer, I mean the actual answer. What would your score be? What's the best you can score? And also, I forgot what I was going to say. So here's the second one. I live in California, so sorry, that's why there's questions in California. I know there's some people from Texas. Okay. Texas, the country of Texas. I love Texas. I wanted to move to Austin, by the way. Yeah, I was in Austin and I loved it. I really loved it. It was like Portland, Oregon, I was told. And it was rainy. Yeah, but it doesn't have Oregon ducks, so I'm not sure about that. Anyway, yeah, so what is the Arab state? I mean, right, those of you who are more into this, you probably get pretty close. And here's the third one. And I can just see a lot of content, right? You can do this in any subject. Get some content out and some facts, some number facts out. For the kids, just kind of, that gut punch, do we know the number of Americans living below poverty? And anyway, okay, so you get the idea, right? And then these are just some sample questions. It's just an estimation activity that you can do any grade level. That's why I love it. Yeah, I love the last one. Around how many footballs can the Grand Canyon hold? 90 trillion. I looked that up. I looked all these up. And you can also have kids write these questions, right? And they look up the answer and they submit it. So you don't have to do any work. I love it when you just dole out the work to the kids, make them do all the work. Yeah. What else? So that is all I have, and I have 10 minutes to spare. I've never, so, let's all celebrate and get a drink. Water, by the way. Questions for me, answers for me. I need more answers and questions.
So while people are thinking up questions, I'm kind of quickly scrolling back through the chat.
Yeah.
If people want the slides, can I go ahead and put them in the handouts for
Yes.
people
Yes.
to download?
Yes.
Right.
Please.
So for all the participants, I'm adding them right now. I just gotta find, there they are. Oh, wait, no. That one's okay. I'm adding them right now as a handout. So if you go to across the top where the chat is, there should be something that says handouts. And now there should be a handout there that are the slides. So you can grab the slides from there. Also somebody, oh, all right. People have started putting questions in the chat. Melissa wants to know if you have the students use different color pencils when they do the patterns.
Do I? Yeah, that's what, right. The colors that you see, right.
Mm-hmm.
The markers, whatever, it's just to distinguish. And sometimes they don't have a color pencils. I have a box on their desk. It's a team box. It's full of color pencils, but by Christmas time I have to replenish because they ate them all. And but or they can just sometimes they just have a pencil and they make hash marks with it, or just they get very creative with it because we just want to see the different parts.
Yep. And then Jocelyn was wondering if there is like a sequence you use to build up the patterns, like so maybe something you always usually start with at the beginning of the year, and then
thank you for asking that. You know what? I do have a suggested sequence, so I'm going to make myself a note right now, and I'll add that. Yes, I do have. And by the time you do these 20 or 30 that I've suggested, I mean, school year's over, but you will get a sense of where your students are, right? But if you're new to visual patterns, I do have a suggested sequence so that we do start out with just linear equations, but then it's time to start because it's just a rectangle, those quadratics. Yeah, yes, I do. So I will. Okay, I'll give it to you, Sheila, later.
Okay. And then it looks like Jackie's wondering. Oh, hold on. Do you guys, so on that website, do you know if there's any visual patterns that lead to statistics discussions about data displays? Or do you know of any?
No. Interesting. So patterns that lead to statistics or
with data displays.
Right. No, I can't think of anything offhand. Oh, good question. Well, make one. See, that's your job. When you can't find something, you have to build one.
And then Tracy's wondering how, so the question is, are your language learners able to understand the equations equally?
Yes. Well, I'm hoping that.
What strategies do you use with them?
Right. Hopefully that's the beauty of it, is because it's minimum on the language, because I'm just asking what is staying the same and what is changing, right? I'm just boiling it down to those two equations, and then we're boiling it down some more, breaking it up into those colors, so that they just really, their eyes can just focus on one color at a time, and they get to, just any part that you can build on. And then the next time you do it, when you see your kids kind of struggling with similar things, you find a similar problem pattern next time. Yeah, so we kind of intentionally build that in when you know your kids, so that they build on a similar pattern the next time, so it's not completely different.
All right. And then Mitch was wondering, do you, when you do the patterns with your students, do you show them on the board, or do you pass out copies of papers for them? Like, how do you logistically manage it all?
Right. So one of the slides I showed a half sheet just to save paper. So on the half sheet, they have three sets, right? 3 copies of the same pattern. And so they just immediately, because it's a warm up, they know when they walk in, that same sheet that is on their desk, and I have it on the dock camera, so they know, oh, that's what we're doing. They go in, and I set the timer for them to quietly work on it. Yeah, so it's on that half sheet, more of at least three copies of the same pattern, so that later, if they can just figure out one, that's wonderful, right? That's all I really need, just one. But the encouragement is that they have 3 copies there if they can see it a different way. And when kids are sharing, that if they what the rest of us need to do is, if we don't see it the same way, if we didn't see it the same way as the student is sharing, then that's why we have that space, is we go ahead and color ours in and shade it in, and actually put in the name of the student who shared that, that Jose to share this. And so we write Jose's name and the equation, and yeah, we mark it up. And sometimes they ask for another one because we need more than 3. And with my 8th graders, actually, the older kids, I have this page, this kid just, I mean, he had at least, I don't know, 10 different equations. And his paper was just a mess. I mean, a beautiful mess of just so many different ways to write that equation. Yeah.
All right.
Yeah.
I think that was all the questions.
Okay. Yeah. What's for dinner, people? For those on the West Coast and those of you on the East Coast, I so appreciate it. I mean, I don't know. I love sharing stuff, and it's just, I'm hoping, to spread the love, that you will do the same, that you will share this with your colleagues. Right, math is amazing.
Yeah. Thank you so much for sharing with us tonight. This was wonderful.
Yeah, thank you.
I'm so excited about it. And so for those of you, there were a couple of people asking in the chat. You should get the link emailed to you to get into this, like to become. So we did record it. I'm actually going to go ahead and stop the recording right now because I don't need to hear this part.
Mm-hmm.
So the recording, who just want to take the opportunity to share with each other things we know and build a community through the internet. And we have an amazing presentation tonight about visual patterns. So Fawn, I'm going to let you go ahead and take it away.
She didn't mean that amazing part. Thank you so much, everyone. Yeah, especially to those of